So the question says, since Grisha behaved well last year, at New Year's Eve, he was visited by dead Moros who brought an enormous bag of gifts with him. The bag contains N sweet candies from the good old bakery, which labeled each labeled from 1 to N, corresponding to its tastiness. No two candies have the same tastiness. The choice of candies has a direct effect on Grisha's happiness. One can assume that he should take the tastiest ones to be more happy. But no, the holiday magic turns things upside down. It is the Zor sum of tastiness that matters, not the ordinary sum. Which means 1 plus 2 plus 3 doesn't matter. 1 Zor, 2 Zor, 3 matters, and this is how we calculate the total tastiness. A Zor sum of a sequence of integers a1, a2, am is defined as the bitwise Zor. Here, this symbol denotes the Zor. Yeah. So Dead Morris warned Grisha he has more house visit. So Grisha can take no more than K candies from the bag. Help Grisha determine the largest Zor sum he can obtain. Here we have N and K in the input. So this is a very easy question, like just a very easy observation we need to make. We have candies from one. Uh, yeah, yeah. So we have candies from 1, 2, 3 till n, and Grisha can take k candies at max, right? So that the Zor sum is maximum. So what is the property of Zor? That 1 Zor 0 or 0 Zor 1 is equals to 1. Else 1 1. So similar elements Zord will give us 0, and 0 1 or 1 0 will give us 1. So we know that the maximum taste will be, like, for an individual candy, n will have the maximum taste. So we are sure that we have to take n, right? Is it? No. So what we can see is, let's say, this is the bitwise notation of n. Okay. So if we try to take n, and and if we, let's say, have one more number, this, then these two numbers Zord uh, will decrease the total sum, because this 1 and 1 will become 0, this 1 and 1 will become 0, right? So this will decrease the total sum. So what can we observe here is that if we are reaching at this particular bit representation for n, so there must be a number which had a bit manipulation representation like this, like, because this is a greater number, right? And if we have this number, then we must have this number too, right? So we can have a maximum we can have the maximum taste if all of the bits are set to 1, right? So this is the way how we can set all of the bits to 1. So we just need two operations, right? And what if we have only one operation? Then obviously the n is the maximum that we can get. So can we see that how simple the solution is? So if k is equals to 1, then we can directly print n, and otherwise else we can print this number. Let's directly look at the code. So we can see if k is equals to 1, then we can directly print n. Otherwise, what we can do, we can print this number. How can we print this number? Like for each one, we are basically adding 2 raised to the power that particular index for that bit. Okay, what am I doing here is, let me just, if this is unclear, let me just show it. Let's say we need to print this number. So what we are doing, these are the indexes. What we are doing, 2 raised to the power 0 plus 2 raised to the power 1 plus 2 raised to the power 2 and so on till 2 raised to the power 5. This is this number. If you are unaware about this, then you need to study bit manipulation, the concept. But yeah, so what we are doing, we are starting from 0 and we are moving till the n, like the till the number of bits in the, like, maximum bit in the n. So what we are doing is, we are calculating, let's say this is our n, right? So we are calculating how many bits is there in this number, and for uh, not exactly how many bits, but like which is the maximum bit. Let's say this is 0, 1, 2, 3, 4, 5, 6, 7th bit, right? So we'll add 7 ones. So we will uh, add 2 raised to the power 0, and then we'll remove this by right shifting this number, and then we'll add 1 to this exponent and add this, and then we'll again remove this, then we'll add this, and we'll again remove this till this number becomes 0. This is what we are doing. While n is not 0, do this, right shift n by 1, and add 2 raised to the power this factor, and then finally print the answer. Yeah, this was about this question.